All right, amplitude. The amplitude of the graph of each function is 1/2 of the difference of the maximum value and the minimum value. Okay, that sounds really complicated. So in other words, the amplitude is found when you subtract the bottom value from the tippy top value and divide that number by 2. So it's the y value, the top one, the bottom one, you subtract the bottom one from the top one, the y value, and then you divide it by 2. Now, if you look at this graph, okay, usually the x-axis cuts the function right in half. So your amplitude is usually just your y value right here, okay? But if you translate that up, then obviously your amplitude is not your y value because the x value does not cut it in half, if that makes sense. So like if I'm going from -1 to 1, and then I'm going from 0 to 2, the amplitude's not 2. The amplitude's still 1, because if I subtract 0 from 2 and I cut it in half, then it's still 1, if that makes sense, okay? So, but if it's x is right in the middle, then your amplitude is just the y value. Okay. A function is periodic if its graph has a repeating pattern. In other words, if you could cut a graph into identical pieces infinitely, the function would be periodic. So if this little, you've seen those paper people, if this went on forever, then it would be periodic, okay? All right, the shortest repeating portion of the graph is called a cycle. So in other words, a cycle would be only one of these people. Okay, this is a cycle. All right, and I know you're writing these, hopefully you're writing these in your notes. If you need to pause the video, I'm just gonna keep going. The horizontal length of each cycle is called the period. So yes, this is a cycle, but the length of it is the period, all right? So in other words, the measure of one of these paper people's arm spans is the period. Okay, so this is a good picture of these things kind of summarized. So this is the sine functions going through 0, 0, remember? Okay, and the amplitude is 1 because the x value is cutting it right in half, so it's going to 1. And if you start at 0 and you do one cycle before it starts to repeat, it goes to 2 pi. So the period is 2 pi. Now this one also talks a bit about the minimum value and the maximum value. We really don't talk about that much. And the range goes from -1 to 1. And we would use that when we were trying to find the amplitude. So it would be 1 minus a -1 would give us 2, and then 2 divided by 2 is 1. That would give us our amplitude. All right, and here's the cosine function. If we start at 0, we would start here and we would coast down. Okay. All right, so in this one, determine whether the graph represents a periodic function. If so, identify the period. Well, we've got this kind of W looking thing, and then we have the same thing here, and it implies that it does the same thing over and over. So yes, it's periodic. And to find the period, I like to start at 0, no matter where it's starting, because then that's just an easy place to start measuring. So if I start here, and I kind of go along, it ends here. And if I draw a little line, it's just a little bit past 6. Well, what's a little bit past 6? 6.2 something? Well, that's 2 pi. So this cycle is about 2 pi. I mean, this period is about 2 pi. Okay, so y equals sine of x and y equals cosine x are parent functions, And like all other functions, they can be transformed. We've talked about this a gazillion times. Okay, so the vertical stretch by a factor of A, and again, we've talked about this a lot too, the stretch and shrink, vertical stretches and shrinks. We have a number out in front of the function. If the number is bigger than A, it's a stretch. If the number is smaller, or between 0 and 1, okay, so 1/2, 2/3, 3/5, okay, then it's a shrink. Now we haven't talked about horizontal stretches and shrinks before, and it's a little more complicated, okay? A horizontal stretch by a factor of 1/b. This is kind of weird, okay? And it'll be easier if I show you an example, okay? So a horizontal stretch by a factor of 1/b. So first let me point out that horizontal stretches and shrinks are the numbers that are right next to the x, okay? So here, A is your vertical stretch or shrink, B is your horizontal stretch or shrink by a factor of 1/b. Okay, and the only time you're really going to need to worry about this is when you're describing the transformation. When you're finding the period, you won't need to worry about this. Okay, so let me just give an example. Okay, say you had the function y equals 2 sine of 3x. And you had to describe the transformation, okay? You would have a vertical stretch by a factor, you could say just by 2, okay? That takes care of this number, okay? Then you would also have a horizontal, okay? It looks like a stretch, but it's actually a shrink by 1/3, okay? I should do this. Okay, what you do is you take that number and you take the reciprocal, and the reciprocal of 3 is 1/3. All right, so you flip it, and because it's flipped, because it's between 0 and 1, it's a shrink. Okay, so let's look at another example. Let's say I have y equals 1/3 cosine of 1/4 x. This would be a vertical shrink by 1/3 and a horizontal stretch by 4, okay? Because I'm taking the 1/4, I'm flipping it, I'm taking the reciprocal, and that 4 becomes a stretch because it's over 1, okay? I know it's a little weird. All right. Amplitude and period. So A and kind of B mean other things too. So the amplitude and period of the graphs of y equals a sine bx and y equals a cosine bx, where a and b are non-zero real numbers, so they can't be 0, are as follows. The amplitude is the absolute value of a. So a is the amplitude. But the period is 2 pi over the absolute value of b. And most of the time, b is positive anyway, so you really don't need to worry about that too much. Just remember 2 pi over b when you're finding the period, okay? Amplitude is a. That one's easy. When you're trying to find the period, it's 2 pi over b. All right. So identify the amplitude and period. Oh, know what? I've gone over my time. Let's do this on the next video.